Section 10.6 is about circles and arcs. So before we get started, I just want to run through some vocab. So this top part is all just talking about what's in a circle and the vocab for it. So it says, a circle is the set of all points equidistant from a given point called the center. So in this picture, P is your center. You can name a circle by its center, so circle P, or you can draw it with the picture and then is shown below. A diameter, which we've already discussed, is a segment that contains the center of a circle and has both endpoints on a circle. So that means that the diameter would be the line segment AB. Then a radius is a segment that has one endpoint at the center and the other endpoint on the circle. So an example of a radius would be PC. Then it says congruent circles have congruent radii. A central angle is an angle whose vertex is the center of the circle. So that means like angle APC would be an example of a central angle. So then more vocab is a semicircle. So a semicircle would be one where you draw a line through here. So that arc would be RST, and so that would be half of it. A minor arc is smaller than a semicircle. So an example of a minor arc would be from R to S. So it has to be less than half of a semicircle. Or sorry, it has to be less than a semicircle. A major arc is larger than a semicircle. So that example would be STR. So it has to be more than 180 degrees. So when you're naming these, a minor arc will always have 2 points, and then when you're doing a major arc, you always want to have 3 so that you have that middle part to know where you're going. So major arc has 3, minor arc has 2. Okay, so this first part is you're just going to get used to some of that vocabulary. So the first piece is what are the minor arcs of this circle? So one way you can do it is you can draw this circle out again like I did over here on the side, and then just use different colors so that you can see where all of them fall into place. So one of the minor arcs would be from A to C, right? Because it's less than a semicircle. Another minor arc would be from C to E. Another minor arc would be from E to D. Another minor arc would be from D to A. So I just listed all 4 of those. Now granted, you can have minor arc DA and arc AD is the same thing. EC and CE are the same thing, so it's up to you what you want to do there. The biggest thing is just start at one point and then work your way all the way around. So the next question is what are all the semicircles? So the semicircles, remember, are 180 degrees or half of the circle. So for example, a semicircle would be there. So arc ACE would be one of them. Then I could do CED. Sorry, I didn't draw that right. ACE would be one of them. Then I could do the next one, which would be CED. Then I could do the next one, which would be EDA. Then I could do the last one, which would be DAC. So sometimes it helps using those colors just so you can see how many arcs there are. If it just confuses you, just start in one point and work your way all the way around. Again, there are different names for these. So like arc DAC is the same thing as CAD, just like when we have angles, you can reverse the order on it. Okay, last one is what are all of the major arcs? Now it does say what are the major arcs that contain point A. You just need to list all the major arcs. So don't worry about the containing point A, just scribble that part out. So I went ahead and drew out my circle and was doing it with it because the book really confused me. But again, you're just doing the same thing. Start at one point and find a major arc. So like if I started at A, I would find a major arc, so I would want to go bigger than 180. So the first point that's bigger than 180 would be D. So I could name it arc ACD, I can name it arc AED, and I can reverse that order. So all of those are the same thing. Then I would do the same thing for the next. So I would go to the next point. Go at C, go all the way around until you're bigger than 180, so that would put me at A. So I could do CEA, I could do CDA, and then I can reverse that order. Then I would start at E, and I would go bigger than 180, so that'd put me at C, so I could do EDC, I could do EAC, and then last I would start at D and go around, and that puts me there. So you should have 4 arcs. You might have different names than mine, but it should be all the same. So just matching those up, making sure the middle number or the middle letter is the same there. Okay, you're going to pause the video and try the got it question. So in the got it question, it's asking you to find all of the minor arcs. So you would want to list out SR, SP, PQ, RQ, and then SQ. So make sure you have them all listed. So you should have 5 in there. So those are easy because you can start all the way around, but then on this particular one you do have some inside there. So make sure you include SQ and make sure that you include going the other direction. So then for your semicircles you should only have 2. You should have arc RSP and arc PQR. And then on the very last, you are listing all of your major arcs. So you could start, I did it 2 different ways so you could see it. So I just started at 1 point, and so I started at S. So one major arc would be SRQ. Then I went to R, so the next one would be RQS. The next one at Q would be QPR or QSR. The next one would be PSQ, and then the last one would be SRQ. I guess I just listed that, didn't I? That's not right. So just make sure that you're listing all of them. You should have all 5 of these sets. I was looking at the wrong piece, sorry. You should have all 5 of those sets, so just make sure that you have all of those sets in there. Okay, so the next piece is finding your arc measure. And what that says is that the measure of a minor arc, so a small one less than 180, is equal to the measure of a corresponding central angle. So if this angle is 50 degrees right here, that means this arc from R to T, if I were to measure it with a protractor, would also be 50 degrees. It says if you wanted to do the measure of a major arc, so like all the way around here, then it is the measure of the related minor arc subtracted from 360. So I could just find this by doing 360 minus 50 and I would get 310. And then the measure of a semicircle is always 180 degrees. The other theorem that's in here is arc addition postulate, which just says if you have 2 adjacent arcs, you can add those 2 together and get one big major arc. So we're going to find some measures of some arcs using this circle. And so it wants me to find the measure of BC. So here is BC. The angle, that central angle that fits to it, is 32. So that means that the measure of arc BC is 32. Then it wants me to find the measure of BD. Well, that would be this angle here, so I can just add 32 and 58, and I would get 90 degrees. The measure of ABC, well, that's a semicircle, so I know that's 180 degrees. And then last, AB, I noticed that here is a semicircle, so I could just do 180 and subtract away this missing piece, and then I know I would have left over AB. So I took 180 minus 32 and I got 148. Okay, pause the video and see if you can do the got it question. So in the got it question, the first one asks you to find the measure of PR, so that should just be 77, the same. Then it wants you to find the measure of RS, so I would take 180 and subtract away that 77 and get 103. It wants you to find the measure of PRQ, so that means I'd add 180 plus 28, so I'd get 208. And then last it wants me to find PQR, so I just took 360, my whole circle, and subtracted away this angle right here, and I got 283. Okay, we've done circumference before, so this is just a review of that theorem. So to find the perimeter or the circumference of a circle, you're going to do pi times the diameter or 2 pi r. So we're not going to refresh that because we've already done that in the past. The last piece of this is finding an arc length. Now, the difference between what you were doing previously is I would be getting out a protractor and measuring how many degrees there are. For this, I would have to stretch this arc out into a straight line, and I would be getting out a ruler and measuring how long it is. So there's a difference between the two. So if it wants me to find the length of the arc, so that would be like if I cut this out, stretched it across here, how much would my ruler say it would be? So this formula will help us find that. It says you're going to multiply the circumference of the circle, so that's this same formula, times the measure of the arc divided by 360. So let's see how you would use that. So here's my first problem. I need to know, I want to find the measure of what's in red, so it might be hard to see, so make sure that you highlight from X to Y. That's what I'm trying to find, the length of that arc. So first I need to know the measure of that arc. So remember that if this is 90, then that means the measure of that's 90. So the measure of the arc would be 90 over 360. And then I'm going to do pi times, since they're giving me diameter, I'm going to use the pi times diameter formula. So I'm going to do 90 divided by 360 on my calculator. Then I'm going to take it times pi and times 16. You should have a pi button already on your calculator, so look to see that you have that symbol somewhere so that you can use that rather than typing in the decimal. So rounded, you should be getting 12.6 inches. Now I say rounded because I know in the directions it says leave your answer in terms of pi. We are not doing that, we're writing it as a decimal, so you can just scratch that part out and do the same on your assignment. Okay, on the next question then, want you to find what's in red. So again, if you can't see that, make sure that you highlight from XPY, that arc right there. So first thing is I need to know the measure, which they told me is 240. So I'm going to do 240 divided by 360. Then I'm going to take it times my circumference. Well, in this case, they gave me the radius, so I'm going to use 15, and I'm going to do the formula where it says 2 pi r. So I do 2 times pi times my radius, which is 15. Plug that all in my calculator, and I get 62.8 centimeters. All right, pause the video, see if you can do the got it question. Ask me what's the length of a semicircle with a radius of 1.3 meters. So I know a semicircle is 180 degrees, so I could do 180 divided by 360, and then I would use the 2 pi r formula since they gave me radius. So I would do 2 times pi times my radius, 1.3, and I get 4.1. Okay, there's a lot in this section. So vocabulary, making sure you know minor, major arcs, that kind of thing. The biggest thing is finding the angle measurements. So just realize that the angle, the central angle measurement, should be the same measure as your arc. And then you can find your arc length using the last formula that we just discussed.